Jeff Hamrick at Rhodes College, and I'm going to spend a couple of minutes doing a very elementary introduction regarding how you get the fitted coefficients for a time series model, a classical time series model, for a data set of interest. I'm not going to focus on diagnostic issues here, but just rather how you use Stata to get those fitted coefficients. So I'm going to go on ahead and import into Stata one of our time series Stata sets. This one has to do with the average number of spots observed on the surface of the sun in some particular month. So let me go on ahead and import this into Stata. And it's a one variable data set that does not have a time variable. I happen to know that the time variable of interest here is essentially month to month. So I'm just going to create a generic time variable so that I can declare this to be a time series data set. Okay, and then let's first check out this data set, see what it looks like. So I'm going to graph a two-way line plot. The variable of interest will be this funky variable name, and the x variable, that is the time variable, is just time, and there we go. And as you can see, sunspots, the number of them that we see each month on average, have an interesting periodicity to them. And I'm not going to talk about that periodicity here. We really need to account for that by using some sort of Holt winterization of these data, or to use what we call a ARIMA model that accounts for the seasonality in this data set. But I'm going to ignore that and just assume that perhaps we end up deciding to fit this model with, let's say we decide it's an ARIMA model that does not require any differencing, but that is of order 2 AR coefficients and 2 MA coefficients. So how do we fit this in Stata? We simply do the following. I use the command ARIMA, and then the name of the time series that I would like to establish the fit for, and I'm going to then use the comma and the option ARIMA 202. We'll talk about the 0 in the middle, but what the 0 in the middle means is that I do not want to difference my data set. That is, I want to model the raw data rather than the first or second differences of that data set. The 2 here means that we're going to use 2 autoregressive coefficients, and the 2 right here means we're going to use 2 moving average coefficients. So we press enter, and Stata begins using an iterative procedure. We're seeing the iterations run here to obtain fitted coefficients using numerical maximum likelihood estimation techniques. So it's done here. This is the top portion of the output. I'll press more so we can see the entire set of output. Here's what the outputs suggest. If I fit 2 AR coefficients, okay, and 2 MA coefficients, the first AR coefficient is certainly statistically significant, and both of these MA coefficients are statistically significant at the 10% level, though if we had a more rigorous level of significance besides the 10% level, we might have only 1 AR and 1 MA coefficient. So these are the fitted coefficients, so to speak, these guys right here. The standard errors of those coefficients, the asymptotic standard errors, are given right here. These approximate z statistics are given by taking the coefficient and dividing by the standard error, and then the two-tailed probability values, the p-values associated with those z statistics, are given in this column right here. Obviously then we can easily get 95% or approximately 95% confidence intervals for those parameters, the true population parameters of interest here. The one other thing I'll point out a couple things using the top portion of this output. This is the value of the log likelihood that is being maximized in order to obtain these fitted coefficient values. This is the number of observations in our data set. This is what's called the Wald statistic for this particular model. It's based on the number of parameters minus 1 that are fitted for the model. So this model has 1, 2, 3, 4, 5 because there's a constant mean value for this model that's assumed by Stata. So we have 4 parameters that had to be fitted here. And so this works as a test statistic like the F statistic for regression. It's a statistic for the overall significance of the model, and you won't be surprised to see that it's highly significant for the model. In other words, this particular ARIMA model does add some value to explanation above and beyond a mere dummy model that only assumes that the data are constant plus a white noise. So this is roughly speaking how you use Stata to get fitted coefficients for ARIMA models and how you interpret the output. Please let me know if you have any questions.